All right, welcome to The Explainer. Today, we're digging into a really interesting puzzle from the software world. How can you have perfectly written code, like literally flawless individual pieces, but when you put them all together, you get a completely broken application? It sounds impossible, right? Well, let's find out. So, picture this. You've got a team of superstar engineers. I mean, each one builds a perfect part. The login, it works. The database connects without a hitch. The user interface, it's gorgeous. So they put it all together and bam, it crashes. The whole system just falls over. How on earth is that even possible? Well, here's the kicker. It's because a single part working perfectly by itself, that's not the whole story. Not even close. It's kind of like a world-class violinist practicing alone in a room. I mean, they might sound incredible, but that tells you absolutely nothing about what's going to happen when the entire orchestra starts playing together. The real magic, or the total disaster, happens right where those pieces meet. Okay, so to really wrap our heads around this, we first need to understand the exact problem that integration testing was created to fix. Let's dig into why these seemingly perfect parts can just fail each other so spectacularly. In software, the very first line of defense is usually what's called a unit test. Just think of it like a quality check on a single Lego brick. This test will tell you, yep, this brick is the right shape, the right color, it's perfectly made. But here's the thing it doesn't check. Will its little studs actually connect to the holes on a totally different kind of brick? And that is the gap. Unit tests check the parts, but they don't check how those parts connect. And this is not just some theory, it's actually at the core of so many real-world tech failures. There's this great line from FSOF course material that just nails it. Many failures don't come from the components themselves, but from faults in the interaction of subsystems. It's that handshake, that little conversation happening between two different chunks of code. That's where things so often go completely sideways. So, okay, if just testing the individual parts isn't going to cut it, what's the answer? Well, this brings us to the hero of our story today, a process built specifically to test those super critical connections. And that solution is called integration testing. The secret, honestly, is right there in the name. You don't just test the parts by themselves, you start combining them, piece by piece, and you test them as a group. The whole point of this is to deliberately find those hidden flaws, the ones that only pop up when different components actually have to start talking to each other. So what does that actually mean in practice? What are we looking for? Well, integration testing is laser-focused on a few key things. First, you've got the interfaces. Think of them as the digital doorways between all the modules. Is data getting through them correctly? Second, the combined features themselves. Like, when you click the Buy Now button, does it actually talk to the payment system and the inventory system like it's supposed to? And third, the big picture, the overall architecture. Is the whole thing being built according to the master plan? All right, so once a team commits to doing this, they immediately hit a big fork in the road. See, there isn't just one way to snap these components together. There are two really different philosophies on how you should go about putting the puzzle together. Okay, so on one side, you've got what's called the Big Bang approach. And yeah, it's pretty much what it sounds like. You build every single piece separately, then at the very end, you just throw them all together and pray it works. Now, it's really fast to get started, but man, if something breaks, finding the cause is a total nightmare. Then, on the other side, you have the incremental approach. With this one, you add one new piece at a time and you test every single step of the way. It's way more methodical and you find bugs really early on, but it definitely takes more setup to get going. Now, for the teams who go down that more careful incremental path, which is pretty wise, there's actually another layer to the strategy. If you're going to build this thing piece by piece, you have to ask, where do we start? Do we build from the top down or from the bottom up? But hey, before we get into those two directions, we need to talk about their special tools, stubs and drivers. All these are really our stand-ins. They're just simple, temporary little pieces of code that pretend to be a module that hasn't been built yet. A great way to think of them is like temporary support beams you'd use in construction while you're waiting for the real, permanent walls to go up. So those little temporary tools, the stubs and drivers, they're absolutely essential for the two main incremental strategies. First up, you've got top-down integration. Here, you start with the highest level, like the user interface, and you work your way down. Use those stubs to fake the lower-level parts that don't exist yet. The big win here is that you get to test the overall flow of the entire application really, really early. The other way to go is bottom-up integration. You start with the most fundamental pieces, like the database, and you use drivers to send it test commands from above. The advantage here is you know for sure that your most critical foundational parts are absolutely rock solid before you build anything else on top of them. So, we've looked at the problem, the solution, and all the different strategies. After all that, what's the one big takeaway here? What's the main idea you should walk away with? It really all boils down to this. Building reliable software isn't just about making great parts. It's about making parts that work great together. I mean, you can have the best engine, the best wheels, the best chassis in the entire world. But if the bolts don't fit, you don't have a car. You just have a very expensive pile of parts. Great software is a team sport. And that's not just true for the people building it, it's true for the code itself. So I'll leave you with this little thought. The next time you're using an app that just works, it's seamless, it's flawless, just take a second and think about the hidden complexity there. Don't just ask what the app does. Ask how all its little pieces learn to work together so perfectly. Thanks for joining me on The Explainer.